Hey everyone, Dr. Crahay here. I wanted to add a bit to these Khan Academy videos. There are a few types of visual displays that they didn't get around to discussing. The first of which is a pie chart. So you've probably heard of these before, just pie, like a piece of pie. So you may have seen this graphic over here on the left. It's kind of, poking fun at the idea. It's a pie chart of the pie you've eaten. So this part right here is the pie you have not yet eaten. And then of course right here you have the pie that you have eaten. So this is what a pie chart is. Taking it a bit more seriously, you have a circle that represents the whole of your data, right? And then you'll have different pieces in your pie chart to show typically different group memberships. So maybe this is, or frequencies to put it in a different way. So here we might have a pie chart of class status, and so what you would have here is all of these different pieces of the pie represent a different class status. So maybe this represents juniors, and juniors make up about 25% of the data. And then of course you would have another little piece right here. Maybe that would represent seniors. So that looks like a little bit less than a quarter. Maybe that's 22% of your data, so on and so forth. So that is a pie chart. They're good for frequency. So to see how common something is, you can very quickly glance at this and say, okay, so in my sample, there are quite a few juniors. We have more juniors than any other membership category. So that's what these pie charts are for, to quickly display this kind of visual information, or this kind of membership information, I should say. They can be useful to get a quick glance at your data, but that's about the end of their utility. So we won't use them as much as some other methods in this class, but in any case you should be familiar with what they are. I also want to talk a second about bar charts. So bar charts. So say for example we have a nice pretty chart here, and we're going to display the grade. So here's person A, and so I think in the Khan Academy video he did something very similar. Person B, C, and we can have a fourth person there represented by D. So what we would do in this case is we would just say, so grade up here would be 100. Maybe it's a final term grade kind of a thing. Of course 0 would be up here. Maybe person A worked very hard, did very well in the class, and they ended up with what looks like an A, so maybe like a 90%, somewhere in that range. We could also have person B. We want to look and see what they made, so you just kind of fill that bar in to whatever their grade was. Moving forward, person C would do the same thing, and then person D, of course, we do the exact same thing. Maybe just to show some differences here, maybe person D didn't do as well. So this is a bar chart. So again, we can very quickly look at this type of information and decide, okay, so of these 4 people, A, B, C, and D, who did the best in the class? Very, very easy to just glance at this and get a sense for the data there. If you look at this closely, you'll notice something that is very important, and that is these gaps here. So let me try to find a different color. So we have gaps in between our people. Now that is very purposeful. The reason is that this is discrete data. Discrete data. So remember, discrete means that it's going to fall into one of a couple of categories, right? In this case, our categories are actually different people. So we have person A, person B, person C, or person D. So it's discrete. You're one person or another. You can't be, this is one group membership. You're yourself, you're no one else, basically. So we use these gaps to show that this is not kind of a continuous scale. We do this with discrete data. You might see this called categorical, nominal, all of those further distinctions that you can make. Again, I'm not as concerned that you understand, is this categorical or nominal data, but I do want you to understand this is discrete data. We have discrete categories there. So this is a bar chart, and that's the reason that you have these gaps here. It's because it is discrete data. If you have continuous data, so remember, continuous data can fall anywhere along the line of numeric possibilities, just about, can take any number of possible values. So for continuous data, you would use what is called a histogram. We'll be using histograms quite a bit in this course. So again, continuous data for the histogram there. So in this, most often what you'll see, so here again we have our little graph. You have the frequency over here. And then let's look at, for example, IQ. So hopefully we're all familiar with IQ tests. Somewhere in the middle we have a score of 100. Maybe over here we have a score of 115. Over here, 85. So you take an intelligence test and you get some kind of score. You can get any number. Typically, you're going to score between 85 and 115. We'll talk more about that as we move forward in the class, but most people will score within this range. You could score an 85, an 87, 88. So this is continuous data. So what you would do when you have data on this, so say one person A, takes an IQ test and they score an 85. Maybe person B scores a 90. Maybe person C, so C through, I don't know, M or something, so you have C, D, E, F, all the way. You have quite a few people there that score 100. Just kind of make a running tally and you go, okay, person A, got an 85, so I'm going to add a little tick mark here. So maybe this is 10 people. We have kind of a small sample here. Person B scores a 90, so then here 85, 100. So maybe a 90 is about there. Person C scores 100, so you add one tick there. Person D also scored 100, so you're going to add another there. Person E also scored 100, so you'll add them up there. Person F, guess what? They also scored 100, so you'll add a tick mark there, so on and so forth. So what you'll end up with typically is that a large number of people, so about 20 people, we go all the way up there, about 20 people scored 100 on this. Maybe 10 people scored in this range. Maybe that's like a 105, 101, 102, those kinds of things. And it goes down, it goes down, it goes down as you move away from this number right here, which is our mean. Again, we'll talk about that in the future. Those frequencies will decrease. But this is a histogram. Continuous data, because you can get just about any number along this line, and as someone scores a particular score, so as you get a person that scores 85, you put a little tick mark here, and this is another one, you put them, third person, you put them there, and so you get this nice histogram showing you the frequency of the data. You do that with a histogram. You might also see this called a frequency distribution, because you're showing how frequent these different scores are. So in this class we will use a frequency distribution, histograms in particular, over and over and over again. Once we start talking about normal distribution, understanding this gets to be very important. So what tends to happen is behavioral data will approximate a normal distribution. You may have heard the term bell curve, so it'll look, something like this, where it's approximate on both sides, and that allows us to understand a couple of different things. Again, we'll talk about this more in depth, but when we have a normal distribution, we know that 50% of the scores lie above 100, for example. Likewise, 50% fall below. So then you're able to say, okay, I scored a 111. What percentage, so my IQ equals 111, what percentage of people scored lower than I did? We could also answer what percentage of people scored higher than I did. So using a histogram and then kind of jumping to a normal distribution, sometimes it's called a bell curve, we can answer these kinds of questions. We'll hit on this in much more detail, but right now the foundational building block is understanding what a histogram is, which is just a visual display of continuous data. Okay, one more thing that I'd like to talk about, and the Khan Academy videos did not touch on this, so I'll spend a little bit more time. Let me clear up some space real quick. Let's just scroll down and do this right here. I want to talk about what's called, let's just get a new canvas, a stem and leaf plot. So let's write that down real quick, stem and leaf. Stem and leaf plots. So these are just, again, another way to visually describe, visually display data so that you can quickly look at it and kind of get a sense of where people fall with their scores. So let me give you an example here. So just some example data. Maybe this is some kind of satisfaction score. It could be a final exam score. It could be I don't know, how well you improved. It could be a change score from pre-test to post-test, that kind of thing. It could be just about any raw score number from participants. So here's one person, second person, 3, 4, so on and so forth. So to do a stem and leaf plot, we just draw basically a T-chart. If you're familiar with those, you'll draw a little T-chart there. On the left side, we'll have the stem. On the right, we'll have the leaf. So what we do, first we have to determine what our stems are. To do that, we're going to look in the tens places. So we've got some 1s, 12, 14, 10. We have a 4, 3s, 2s, 1s, 5s. So we need to go 1 through 6 with these stems. So we're going to have 1, 2, 3, 4, 5, and 6 for our stems. Now what we'll do is we'll go through and we'll find everything that has a stem of 1. So if it has a 1 in the tens place, we know that it needs to go in this line right here. So let's find those. We have a 12, a 14, a 10. This will go in 4, this will go in 3, this will go in 2, this is a 1, and then that will go in 5. So starting with your lowest number within that stem, you're going to list those numbers out. So we have 10, 12, 14, and 16. So we'll do 0, 2, 4, and 6. So that allows you to know, okay, here's the leftmost number, right? So 1, and our leaf is 0, so we know this number's 10. That's representing this number right here. A stem of 1 with a leaf of 2 represents the number 12. That's this number here. Stem of 1, leaf of 4, that's our 14. Stem of 1, leaf of 6 is 16. So then from here we just complete the table. So let's see, we'll look for 2s. We have a 23, so we'll have a leaf of that. So we've got 23 represented. Moving forward, we'll look at 3s. We've got a 33, so we're just going to put a 3 there. Still moving forward, we've got a 47, so we'll put a 7 there. And then pushing forward to our last number, 52. 2. So you'll put a 2 there. So that points out to me very quickly that I've actually made a mistake. I didn't need that 6. So this is our full stem and leaf plot. Now these are really interesting because you can tell pretty quickly what your most common numbers are. So if you can kind of imagine mentally rotating this whole thing, you can see that you've got your lower numbers are more common than your other things here. So you could kind of draw your frequency distribution there, and of course it would go kind of down over there. And you could see that your stem right here, 1, your 10s are your most common kind of numbers there. If you had a mode, so if we had two 23s, we would be able to see that very quickly that was our mode. Be 23, 23. That's the only leaf that repeats within the same stem, so we would know very quickly that is our mode. So this is a stem and leaf plot. Just to be sure that I'm being clear here, let's do one more example because the Khan Academy videos didn't go through these. So let me scroll over to get some fresh space here. So our data set will be 42, 46, 29, 19, 11, 50. Let's do a 2. To see what that looks like, and also a 30. So here's a really great place to pause. So I encourage you guys to actively participate in these lectures. You know, you can sit and you can listen and think you understand everything, and then you'll get to the homework and realize that you may not have been paying as close attention as you should have. So take a second now, if you think you understand this very, very well, go and hit pause, draw out your stem and leaf plot, and then come back to this video and see how well you did. In the meantime, let's go through this. You gotta start with your T, right? On the left hand side, we'll have our stem. On the right hand side, we'll put our leaf. And again, we have to look in those tens digits to find our stems. So here is a 2. That's going to be a stem of 0. So we're going to start this one a little bit lower. So we've got 0, 1, we've got 2s, we've got 3s, 4s, we've got a 50 there. Let's see if we go up to 6. There are no 6s there. So these are our stems, 0 through 5. Now we have to go through and give our leaves. So how many numbers do we have with a stem of 0? So that one's pretty easy. That's going to be just the 1, just this 2 right here. So we'll circle that, put that in there. So that tells you you've got 0, 2, so you have one number in your data set, that is 2. Going through to find all of the 1s, we've got a 19, an 11, and that's it. Again, organizing them from lowest to highest, we'll have 1 and 9 representing 11 and 19. For 2s, looks like we've got 1 there. We've got a 29. Easy enough. Same for 30, we've just got the 1, so it'll be a 0. Because it's 3, 0, 30, we're representing that number there. We have 2 in the 4 category. We've got a 42 and a 46. We have 1 remaining number, which is 50, so that last leaf will be a 0. Okay, so that is stem and leaf plots. Hopefully these make sense to you, but as always, please do take a second, rate how useful these videos were for you, and then of course leave me a question, comment. I'm going to edit these as we go along. I'll add supplements, and your questions really do help me make better lecture videos. So that's all for now, and I'll see you online.